Hello and welcome to the exciting part 2 of 5-1 using fundamental trig identities. And let me back up here. Here's what we're going to do in trig ideas without. Let me do this. Get this out of the way here. Blah 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 blah. Okay, we've got two fractions. We are going to add the fractions together. Let me fix this back up. And you might remember way back in the algebra stuff if we did this, a over b plus c over d. The sort of shortcut algorithm is we're going to multiply these denominators together for our common, b times d. And then I'm going to multiply this numerator by what is missing below it. That would be the d, ad. This is a plus, so I'll keep the plus. And then this numerator gets multiplied by the opposite denominator, c times b. AD plus CB over B times D. We can, ooh, what the heck was that? We can do something similar with what I have written here in blue. So I'm going to do one big divider line, and my common denominator are going to be these multiplied. X times quantity 1 plus y. I would recommend not distributing. We might have a chance to cancel something later in the problem. So this numerator gets multiplied by this denominator. X times x is x squared. Plus this numerator y is going to get multiplied by the other denominator 1 plus y. Then we can distribute, so I would have x squared plus, distribute the y, so that's going to be a y plus y squared. Plus y squared, and then our denominator would be down here. We're going to do something very similar today, but not with x's and y's. It'll have trig functions in it. Doesn't that sound like fun? But before we do that, we're going to do another one here. Let me read this intro first. In some cases, when you're factoring or simplifying a trig expression, it's first helpful to rewrite the expression in terms of just one trig function, or in terms of sines and cosines only. You'll see these strategies demonstrated here. Like this one, it is factoring a trig expression, but what if I asked you to factor x squared minus y minus 3? Can you factor that since these variables don't match? We have x's and y's, so that would be impossible. So what we've got here is the trig equivalent of that algebraic problem I just showed you. Cosecant squared minus cotan x minus 3. So we do want to break this up and factor it, but we need everything to be the same trig function. We need everything on the same page. So what we could do is get rid of either this cotan or get rid of the cosecant squared. And in these cases, you're always going to tackle the squared term because we can use a Pythagorean identity. Notice I did block off the cosecant squared with a set of blue parentheses. So let's go to our formula sheet and figure out what we can replace cosecant squared with. Well, here is the Pythagorean identity with cosecant squared in it. Oh, and it's perfect. Cosecant squared is isolated all by itself, so we can replace this cosecant squared with this quantity, 1 plus cotan squared. So that becomes 1 plus cotan squared x minus cotan x minus 3. Now everything is in terms of cotan, so we can factor after we combine our constants. So here's cotan squared x minus cotan x. We got a minus 3 and a plus 1, so that's a minus 2. All right, time to actually factor it now like we saw in the last video. So I'm just going to set up some empty parentheses. Cotan squared must come from cotan x times cotan x. And then remember, there is an implied 1 in here with this cotan in the middle. So the only way to factor 2 is 2 and 1. And then to add them up and get a minus 1 in the middle, it's got to be a negative 2 and a positive 1. That'll add up to the negative 1 in the middle and multiply to the negative 2 at the end. So there we had to do a little work to get that cosecant squared out of there, and then we factored it like we did in the last video. Here's another one of these race problems where you don't know where the finish line is. So simplifying a trig expression, and they just say, simplify this. All right. Well, what the heck can we do with that? They did say here one of the strategies was to turn everything, yeah, right here, sines and cosines only. If I go back to the formula sheet, everything can be written as a sine or a cosine. If I give you sine, leave it alone. If I give you cos, leave it alone. If I give you tan, don't even look at this one because tan is sine over cos. If I give you cotan, don't look at that one because cotan is cos over sine. Cosecant, I would replace that with 1 over sine, and secant gets replaced with 1 over cos. So no matter what trig function you are given, you can always turn it into some form of either cos or sine. So let's try that strategy here. Sine of t, let's change those t's into x's. Sine of x, I'm going to leave it alone. I'm going to put a 1 under it, though, turn it into a fraction. Plus cotan. Cotan is cos over sine. Sine. And then this cos, we'll just leave it alone. Times cos, that's supposed to be an s, cos x over 1. Okay, we've turned everything into sines and cosines. Now, if you're looking at those signs on the diagonal, think you're going to cancel them. You can't because that's addition. You can only do that across multiplication. So let's combine the stuff after the plus. Cos times cos in the numerator, well, that's cos squared. Denominator, sine times 1 is sine. Okay, we're getting somewhere. Now, it looks kind of like that algebraic warm-up I had. We've got a fraction plus another fraction. Well, when you see a couple fractions with a plus sign in between them, let's add those fractions up. I'm going to do a big old division bar. Common denominator is going to be 1 times sine x, so that's a sine x. This numerator has the 1 under it, but it's missing the sine, so we're going to multiply those. Sine times sine is sine squared. Plus this cos squared has the sine under it, but it's missing the 1. Cos squared times 1 is cos squared. Okay, if it hasn't already gotten deeply ingrained, when you see sine squared plus cos squared, something should jump into your head immediately. Sine squared plus cos squared is equal to 1. And that's over sine. Okay. 1 over sine, that's a reciprocal, which is the same thing as cosecant of x. So there's our finish line. Again, we did not know where it was when the race started, but we went from, get down here, this mess, sine plus cotan times cos. Well, that's exactly the same thing as just little old cosecant of x. So that's simplified down really nice. And I'll give you a clue. You know, this is section 5.1 where we don't know the finish line. When we get into section 5.2, if you saw this same expression, it would say is equal to cosecant x. And in 5.2, the directions are going to say make the left side look like the right side. So we're going to take this and we're going to start working on it. And we know that this is the finish line. That's what makes section 5.2 so much easier than 5.1. Remark. Remember, when adding rational expressions, you must first find the least common denominator, blah, blah, blah. Okay, a couple for you to try, very similar to the examples we just did. So you know the drill. Pause the video, try the problems, and then fire it back up. All right. In the first one, we've got apples and oranges. Secant squared is an apple, tan is an orange. We're going to block off secant squared and replace it with something. If you went to the formula sheet and found the correct spot, secant squared is equivalent to 1 plus tan squared, x. And then we'll copy the rest of the problem. We've still got a 3 tan x in there. And we've got our little plus 1 at the end. So let's see, we've got tan squared. That'll be our leading term. Plus 3 tan in the middle. And then we've got a 1 plus a 1. Well, that's a 2. Ooh, and this is going to be easy to factor because everything is pluses. And the tan squared can only come from tan times tan. Tan x times tan x. We can only factor 2 as 2 times 1. And again, because everything is plus, these have to be pluses. And our outers and inners will add up to the 3 in the middle. So there is that first huddle problem. Now this one, again, very similar to the last one. Let's turn everything into sines and coses. Cosecant, that is 1 over sine, minus, we'll leave that cos alone because cos is cool, times cotan. Cotan is cos over sine. All right, well, 1 over sine, that's going to stay as is, minus, over here, 1 times sine in the denominator is sine. Beautiful. Up top, cos times cos is cos squared. Okay, now in the example, we didn't have a common denominator here, but in this one we do. Nice. So let's just put this over one big old common denominator, sine x. And what's our numerator going to be? 1 minus cos squared. 1 minus cos squared. Now, if you did stop there, I would not hold that against you because we did simplify it at least somewhat. But we can go farther. Again, I'm going to switch ink and come over here and do a little scratch work. Sine squared plus cos squared equals 1. We want 1 minus cos squared. Well, the 1 is positive over here, so let's subtract the cos squared. 1 minus cos squared is equal to sine squared. So this numerator is out. I'm going to replace it with sine squared. And our denominator is sine x. So we are dividing the same bases. So our answer will have the same base, and we subtract exponents. 2 minus 1 is 1 sine x. There's our final answer. So again, the mess we started with, if we punched it in the calculator and graphed it, it would have the exact same graph as a sine wave, which we can do by hand. We don't even need a calculator. Okay, what's next? Oh, more addition. Now it's going to get a little trickier because this is a quantity down here. I highly encourage my students, when we're dealing with a fraction like this and you see a denominator that's more than a term, block it off. It is a quantity. It should remain a quantity. So now the good thing here, everything's in terms of sines and coses. So we don't have to worry about converting anything. I'm just going to do a big old division line here. And our common denominator will be these two multiplied together. I'm going to write my sine of theta first, and then my quantity 1 plus cos. I encourage you, do not distribute. If we are simplifying, part of simplifying is factoring. If we distribute, we're doing the opposite of factoring, we're doing the opposite of simplifying. So we're going to leave that as two multiplied terms. Now this sign is going to get multiplied by what's missing under it. That's another sine. So that is sine squared. Plus this numerator cos theta, is going to get multiplied by the other denominator. And again, that's why I put it into red parenthesis, because that will remain a quantity, 1 plus cos theta. Okay. Now it's just a little more algebra and some more simplifying. I guess I can just work down here below. This first term, sine squared, and that numerator is going to stay the same, sine squared, plus, let's distribute this cos. Cos times 1 is cos, plus cos times cos is cos squared. Ooh. And again, our denominator, we're not going to distribute down there. We're going to leave that as a sine theta times quantity 1 plus cos theta. Okay. Now, we're looking for more opportunities to simplify. If we look in the numerator there, we've got a sine squared plus a cos squared. You know, even if they're not touching each other or right next to each other, we could rearrange the numerator so they are. As long as this is a plus, we've got a sine squared plus a cos squared. So what I circled here in red is going to turn into a 1. 1 plus the other cos that we still have lurking up there in the numerator. And now when I rewrite the denominator, you might see why we did not distribute 1 plus cos theta in the parenthesis. Okay. If I put a set of parentheses around that numerator, it becomes obvious what's going to happen. We are going to have a cancellation. Now be careful. The numerator is what's in the black parenthesis, but there is a 1 out there. Because when we cancel these, that sign is in the denominator before we canceled, it should be in the denominator when we're done canceling. Because that 1 plus cos has been canceled entirely, we do need that 1 as a placeholder. And what is 1 over sine? Oh my gosh, it's cosecant theta. So again, look where we started, that mess. If I said, hey, graph that, you wouldn't know where to begin. But if we simplify it down to cosecant, yeah, we can graph a cosecant of theta graph. That's not hard at all. Good stuff. And let's see if I remember right. Here is one last huddle problem for you, and then we'll talk about the assignment. So again, I encourage you highly to put these in parentheses. Get that common denominator, fix up your numerators, and look for chances to cancel. All right, pause the video. Okay, so our common denominator, ooh, now in this one, whoa, that's just terrible. Okay, we are going to have a 1 plus sine theta, and then a 1 minus sine theta. Now again, in the last example, I encourage you not to distribute. In this case, though, 1 plus sine, 1 minus sine, this we are going to FOIL out because that'll simplify down nicely. Let's not get ahead of ourselves. This 1 up here is going to get multiplied by 1 minus sine. 1 times 1 minus sine is 1 minus sine. Plus, be extra cautious if that's a minus, because then we'd have to distribute a negative 1. But here it's a plus 1 times 1 plus sine, so that'll just be 1 plus sine. All right. So let's see here. In the numerator, let me switch to black ink. We've got a negative sign, and then here is a positive sign. Those are going to cancel, and we're left with 1 plus 1 is 2. Boom. Now let's see what happens if we FOIL out that denominator. 1 plus sine times 1 minus sine. That is 1 minus sine squared theta. Ooh, okay, we're getting somewhere. I see a trig function squared with a 1 lurking around. Might be an opportunity to use a Pythagorean identity. Come over here in red ink and do my scratch work. Sine squared plus cos squared equals 1. Well, we want 1 minus sine squared. So the 1 is good where it's at. We're going to take this plus sine squared and subtract it. So now over here it's a minus sine squared. And that leaves on the other side of equals just cos squared. So this denominator, 1 minus sine squared, that's going to turn into a cos squared x. Now, if you left it like this, I would not be terribly upset. But another way to look at these two, remember this numerator up here too, we can sort of slide that off and make it multiply as long as we put a placeholder up there. Now it might be a little easier to see that we do have a reciprocal here. 1 over cos is equal to secant, so 1 over cos squared is going to equal secant squared. And then don't forget we got that 2. 2 secant squared x. Well, why did I put x? Everything else was theta. That should be a theta. 2 secant squared theta. So again, all of this mess, if we actually add them together, it boils down to a nice little old 2 times the secant squared of theta. Okay, assignment time. Now here are the evens. These will be turned in for a grade, and then the odd ones we will work on in class. If you do miss class, you can always go to Calc Chat or Calc View. Remember, Calc Chat is for all of the odd problems. Calc View is if you see the problems highlighted in red, in the textbook. So we'll do 32 will be graded, 31 will be the one to get you ready for that, 33 will help. These problems are paired, so we'll do an example in class that you can also match up with a homework problem. So I hope you enjoyed the video, and I'll see you in the next one.